Hello science fans! Today, we are diving into the electrifying world of electronics. We are going to talk about a super important component. It's called a capacitor. You might not see them often, but they are everywhere. They are like tiny little powerhouses in your gadgets. Think of your phone, your computer, your television. Capacitors are working hard inside all of them. They are unsung heroes of the electronic age. So, what exactly is a capacitor? Let's find out together, shall we? It's going to be an energetic journey. A capacitor, at its heart, is a device that stores electrical energy. Imagine it like a very small, very fast, rechargeable battery. But it works a bit differently than the battery in your remote control. While a battery stores energy chemically and releases it slowly, a capacitor stores energy in an electric field. This means it can charge up very quickly. And importantly, it can discharge its stored energy very quickly too. This quick release is super useful for many electronic tasks. It's all about managing electrical charge in a clever way. So, what do these amazing components look like? Well, capacitors come in many shapes and sizes. Some look like tiny ceramic discs. Others look like small cylindrical cans, often with two little metal legs called leads. These leads are how they connect into an electronic circuit. You might see them color-coded or with numbers printed on them. These markings tell us important things like how much energy they can store. Despite their different appearances, they all perform that fundamental job storing and releasing electrical charge. It's a fundamental building block for so many things we use. Capacitors are truly fundamental to modern electronics. They are not just there for show, they perform critical functions. Without them, many of the devices we rely on daily simply wouldn't work correctly, or at all. They help to smooth out power, filter signals, and provide bursts of energy when needed. Learning about capacitors is like getting a backstage pass to how your favorite gadgets operate. It's science in action, making our technology possible. Pretty neat, huh? Let's explore more. The science bit. Alright, let's get to the nitty-gritty science of how a capacitor actually works its magic. It's simpler than you might think. Inside every capacitor there are two conductive plates. These plates are usually made of metal. Think of them like two slices of bread in a sandwich. These plates are placed very, very close to each other, but here's the key. They don't actually touch. If they touched, it would just be a short circuit, and that's not what we want for storing energy. So, if the plates don't touch, what's between them? There is a special material called a dielectric. A dielectric is an insulator. That means electricity doesn't flow through it easily. Common dielectric materials include ceramic, plastic film, glass, or even air. This dielectric layer is super important. It keeps the plates separated. It also increases the capacitor's ability to store charge. The choice of dielectric material affects how good the capacitor is and what it's best used for. It's a crucial part of the capacitor's design and function. Now, how does it store energy? When you connect a capacitor to a power source like a battery, something fascinating happens. Electrons, which are tiny negatively charged particles, start to flow. One plate of the capacitor collects these electrons, becoming negatively charged. At the same time, electrons are pulled away from the other plate. This makes the other plate positively charged. This separation of charge creates an electric field between the plates. This electric field is where the energy is stored. It's like stretching a rubber band. The energy is stored until it's released. The amount of charge a capacitor can store is called its capacitance. Capacitance is measured in units called farads, named after the brilliant scientist Michael Faraday. 1 farad is actually a very large amount of capacitance, so you'll often see capacitors measured in microfarads, a millionth of a farad, or even picofarads, a trillionth of a farad. When the circuit needs that stored energy, the capacitor can release it. The electrons will flow out from the negative plate, through the circuit, and back to the positive plate until the charges are balanced again. This is discharging. Real-world superstars. You might be wondering, Bill, where would I actually find these capacitors in my daily life? The answer is, almost everywhere electronic. Consider the flash on your camera or smartphone. That bright, quick burst of light needs a lot of energy delivered very quickly. A battery alone can't usually provide that much power that fast, so a capacitor is used. It slowly charges up from the battery. Then when you take a picture, zap. The capacitor discharges all its stored energy in an instant to power the flash. That's a capacitor in action, folks. Let's think about power supplies. The electricity from your wall outlet is alternating current, AC. But most electronic devices like your computer or phone need direct current, DC. a smooth, steady flow. A power adapter converts AC to DC. However, the converted DC can still be a bit bumpy. Capacitors act like tiny reservoirs or shock absorbers for electricity. They smooth out these bumps and ripples in the DC voltage. This ensures your sensitive electronics get a clean, stable power supply. Without them, your gadgets might not work reliably. How about radios and audio equipment? Capacitors play a crucial role here too. In a radio tuner, variable capacitors whose capacitance can be changed, are used to select different radio frequencies. By changing the capacitance, you change which station the radio picks up. Isn't that clever? In audio systems like speakers and amplifiers, capacitors are used in crossover networks. These networks help to send the right sound frequencies to the right speakers. High frequencies go to the tweeter, low frequencies to the woofer. This gives you much better sound quality, and it's not just small gadgets. Capacitors are used in much bigger, life-saving applications. Have you ever seen a defibrillator used in movies or hospitals? Those paddles deliver a powerful electric shock to restart a heart. Where does that intense jolt of electricity come from so quickly? You guessed it, a large capacitor. It charges up to a high voltage and then discharges its energy into the patient. Capacitors are also vital in power factor correction for industrial machinery, helping to make electrical grids more efficient. They are truly versatile. So, we've seen what capacitors are, how they work, and where they're used. But why are they so incredibly important in electronic circuits? Well, one of their key superpowers is filtering. Capacitors can block the flow of direct current, DC, while allowing alternating current, AC, to pass through. This is incredibly useful for separating different types of signals in a circuit. Imagine a tiny traffic controller directing electrical flow. This property is used in audio coupling, power supply decoupling, and many other filtering applications, ensuring signals go where they are needed. Another vital role for capacitors is energy storage and delivery, as we've touched upon. Think about circuits that need a quick burst of power to start up or to perform a specific task. A capacitor can store up energy gradually and then release it rapidly when the circuit demands it. This is essential in things like switch-mode power supplies, where energy is quickly switched around. They also help to stabilize voltage levels within a circuit. If there's a sudden demand for current, a capacitor can provide it momentarily, preventing the voltage from dropping too much. Capacitors are also the stars of timing circuits. When you combine a capacitor with a resistor, you can create circuits that control how long things take. For example, the blinking light on your car's turn signal, or the delay before your microwave starts. The capacitor charges and discharges at a predictable rate through the resistor. This timing characteristic is fundamental to creating oscillators, timers, and pulse generators. These are all essential building blocks for more complex electronic systems. They help set the rhythm for our electronic world. In essence, capacitors are fundamental building blocks, like bricks or beams in a building. Without them, the electronic world as we know it would crumble. They handle energy, filter signals, manage timing, and protect sensitive components. From the simplest circuits to the most complex supercomputers, capacitors are diligently doing their job. They might be small, but their impact is enormous. Understanding capacitors is a big step towards understanding how all our amazing technology truly works. Science is cool, and there you have it, a little journey into the world of capacitors. I hope this sparked your curiosity. If you enjoyed this electrifying explanation and want to learn more amazing science stuff, please give this a big thumbs up. Don't forget to subscribe to the channel for more educational content. And hey, share this with your friends and family. The more people understand science, the better our world can be. Keep exploring, keep questioning, and keep learning. Science rules!